Hello, and welcome to today's webinar on the Hydrologic and Water Quality System Beta. We're glad you're able to join and hope that it will be beneficial. For those who are not able to attend today's webinar, we are recording the presentation and we'll be posting the slides to the EPA website shown on the screen for future reference. The agenda for today's webinar includes a presentation as well as responses to your questions following as time allows. And we're pleased to have so many of you here today, and due to the number of attendees, we have muted all phone lines except for our presenters line. That means for today's webinar, you will be in listen-only mode. During the webinar, we encourage you to type and submit questions as they come in to you using the questions box in the GoToWebinar control panel. EPA staff will respond to questions at the halfway point and then also again at the end of the presentation. We may not be able to get to all of your questions, but we will be reading them as they come in and will provide as much information as possible. We will also be launching 4 short polls during the course of the webinar. When you see the polls, just select the appropriate multiple choice answer when it pops up on your screen. When the presentation closes at the end of the webinar, you'll see a short survey appear, and your input is very important to us, so we ask that you fill it out at the conclusion of the webinar. And now I'd like to turn things over to Praveen Rana of EPA's Office of Water to begin the presentation.
Thanks,
Praveen?
Laura. Hi, I'm Praveen Rana with EPA's Office of Water. I've been the project manager for HAWQS for about 7 months, so that officially makes me the most dangerous person in water quality modeling right now. Actually, after I present you with a brief background, I'll hand the presentation over to Dr. Srinivasan from Texas A&M University. He is the director of the Spatial Sciences Lab at Texas A&M, and his team, along with other EPA technical staff, have been instrumental in the design and development of HAWQS since the project was first conceived and funded by EPA. We released the beta version of HAWQS on June 16th, and today's webcast is to demonstrate the features of HAWQS beta. I just want to mention again that a recorded version of this webcast will be available, as well as a PDF version of slides on the HAWQS website in a few weeks. The topics for today's webcast are, we're going to go through a brief background of the system, and then we'll follow that up by a step-by-step procedure on how to register and use HAWQS. We'll take a break for questions after that, and then we will show you an example use case, followed by an overview of the next steps for HAWQS. Before I go over the background, I want to quickly go over 3 poll questions. These questions and a brief survey at the end of the webcast will help us plan future releases. So Laura, do you want to take that over?
Sure. So our first poll, we're wondering who runs your water quality models. Is it yourself, meaning you're a water quality modeling professional, or perhaps a colleague who is a water quality modeling professional runs your water quality models, contractor, consultant, or some other type of individual. So choose your answer and we'll share the results. You can get information on the other interested parties on today's webinar. All right, so we have a pretty nice range. A lot of water quality modeling professionals are running them, and you have colleagues, contractors, and others involved as well. Thanks for that input. We are also curious, which water quality models do you use for your projects? And you can select all that apply here. Again, a nice range of data The most common being SWAT and basins. Thanks. And finally, so we have a good feel of what your involvement is. Which area of modeling are you specifically involved in? Stormwater, TMDL, climate change, agriculture, or other. And again, this is also where you can select all options that apply to your work. So it looks like TMDL is the most common, and stormwater is also, but we have a range of other topics represented as well. Thank you, guys.
All right, great, Laura. Thank you very much. We could only put up to 5 responses on there, so we see there's a lot of others that have also been clicked. So hopefully over time we'll figure out what that other is.
Yeah, and you can feel free to enter that into your questions box if you want to tell us what that other is, and we'll have that information in our records.
Great. So let me jump into the background. So the scoping work for HAWQS began in 2005, but it wasn't until 2000 that development on the current version of HAWQS started. The key theme, or the business case that was articulated in 2005, continued to guide the HAWQS project. So basically, EPA wanted a system to model regional or national level impacts from policies and regulations, and to support large-scale economic benefits analysis, and also assess policy and program performance. So HAWQS is one of several decision support tools that EPA would like to use to meet these objectives. I also want to emphasize that a major goal for us at this time is to get more input on HAWQS from as many potential actual users as possible. As you can see, it's gone through peer review. So while the peer review process has been useful, we really want more input from actual end users to identify real use cases. So webcasts like this one and other communication methods will be used to accomplish this in the future. You can use the email that is on each slide to provide comments and suggestions. Later on, we'll also get into what it means to be a beta tester in the presentation. So, next slide. No, actually the one before. Yeah. No, yeah, one more, sorry. So just an update on, in 2015, we released the alpha version of HAWQS for peer review. There were about 100 items we identified from the peer review comments and prioritized 70, and also identified other features that could be implemented in 4 to 5 months. So we implemented these and released HAWQS beta on June 16th. We plan future releases with more features, and our next release is planned for late 2016 or early 2017. We will continue to iterate and release other versions after that. So basically that wraps up the background of where HAWQS was, where it is currently, and I'm going to hand it over to Dr. Srinivasan, who will take over.
Thank you, Praveen. I'm going to make a brief presentation walkthrough on how the HAWQS are set up or managed, or how one can create a new project, all the way in terms of execution, and finally visualizing the model. And later I'll give you a case study on one of the projects. So as you can see, this is our main website, epahawqs.tamu.edu is our main website where you could go and sign up, register, or you can log in. So you can click on either login if you already have an existing login, or you can register as a new account or new user. And in the same website, you also have a user guide that anyone can download and have the full step-by-step guideline on how to use the HAWQS system, which is pretty much what I'm going to follow through today. So when you log in, actually, all we need is your first name, last name, and email address, and one of the administrators on the HAWQS side will approve the request. So far, everybody got approved. Actually, nobody got denied, so you'll be able to get your approval immediately. And we also have an option to select, to check the box at the bottom here, actually, where you can sign up for a beta testing. We really want your input to enhance the HAWQS system in terms of functionality, or in terms of user design, or in terms of what additional features that you would like to add moving forward in version 1, version 2, and so on and so forth. We really need your input, so we hope more of you could sign up for that, where you can provide your feedback and continue to improve the system. HAWQS user guide is about 40-50 page long, and it gives you, like I said, step by step, and you're able to download them. And it's in joint development between Texas A&M and US EPA, Office of Water. And in addition to this user guide, we also have several help within the HAWQS system. So when you log into the HAWQS, you'll see a help menu where you'll get a lot of SWOT model documentation, like a theoretical documentation and the user input-output documentation, as well as selected SWOT publications and various materials that will be useful for using HAWQS. And we also have, on the right-hand side, as you can see, we also have prepared all the specific data that's used in the HAWQS, as well as the methodology, the calibration, and some of the resources like climate change data and land use and other point source data and so on and so forth is also available as a resource for the help resources to administer, to manage HAWQS. This one slide gives you a pretty overview. I know this is a very busy slide. I don't expect you to read through this. All you will be needing is a web browser that would be connected to an internet, that could be coming from your smartphone, like iPhone or Android phones, or it could be tablets, or it could be your laptops or desktops. It can be PC, Linux, Unix, Windows, or Apple iOS, or any operating system would work, actually. So you'll be using a web browser to communicate with the server, the HAWQS server that's hosted at Texas A&M University, where you'll be selecting your watersheds, you'll be selecting the various inputs that's required, which I'll be walking through in the next few slides, next several slides. And then once you select your watershed and set up your inputs, you can run the model directly on the A&M web services, or on a A&M cloud system, or you can also have the opportunity to download the entire model to your local hard drive and use a program that comes with SWOT called SWOT Editor, and you can use that to do it offline. So you can do it either online or offline completely with the HAWQS system, actually. I'm sure most of you maybe heard about it or familiar with SWOT model. For those of you who may not have heard, SWOT is a watershed water quality model, and it's been in development for more than 25 years by USDA Agricultural Research Service and Texas A&M University. It's one of the largest body of knowledge of more than 2,700 peer-reviewed publications as of today. The number of publications is almost one a day, actually, or more than one a day is getting published by the SWOT user community. And it uses land use, soils, elevation, land management, and weather input to set up the model. And it is the major strength of the SWOT model is the landscape, where a lot of physical process such as the water, sediment, crop growth, and nutrient cycling are all simulated from the landscape process actually. The outputs can be both water quantity and water quality. Both non-point source and point source can be integrated across from all the way from small scale to very large scale, such as Mississippi River Basin. And you can aggregate the data both spatially and temporally with SWOT. SWOT is the main engine behind the HAWQS modeling. So when you are running the HAWQS, you are actually running SWOT with all the inputs required to run the model. Why do I use HAWQS? HAWQS is an interactive web-based as well as a cloud-based application that can be accessed, like as I mentioned, from any platform or browser. All you need is an internet connection, as simple as a 4G or an LTE connection should be sufficient. You don't have to be an expert in any GIS software, or you don't have to even own a GIS software. Everything is web-based, and always you'll be running the most recent or the latest version of the SWOT, so you don't have to keep track of the various versions of the SWOT actually. The data required to run SWOT is already preloaded. Currently, you can choose from one of the 3 spatial resolution of the model for the US, 8-digit, 10-digit, and 12-digit watersheds. These are all the national watersheds that are developed by the USGS and NRCS, USDA, NRCS. That data set could be selected from any one of those 3. The outputs are already kind of standardized in terms of tables and charts. I'll show you some of those examples later. And you can perform both a baseline and scenarios, and all of them can be kept on the central database that can be retrieved and downloaded or can be used in any projects or reports. And for more complex analysis or more comprehensive analysis, one could also download the entire data compatible on a desktop software such as SWOT editor, and you have unlimited potential of customizing all the inputs and outputs for that model. Currently, only one user can own a project, but we are in the process of upgrading that to have many users in a collaborative manner work on a single project. In other words, one can generate a project and another person could be interpreting or evaluating on running scenarios and so on and so forth. So that capability is still under development, but that's something we recognized earlier from the various input stakeholders, and we are trying to incorporate that in the coming future version. I'm not expecting you to read all this line by line here. I just want to, this input is also available in our HAWQS help screen. These are all the various input that is used in the HAWQS, such as the weather input, soils, land use, atmospheric deposition, watershed boundaries, stream network, elevation, point source, land management, reservoirs, and livestock and crop databases. So all this information, the details of the references is available on the HAWQS help menu. When you log in, this is the first screen that you will be able to see. If you have created several projects, you'll see the HAWQS navigation panel where you'll see a list of all the projects that you have created. Under each project, you may have sub-projects or scenarios that you may have developed. We'll also be able to see them actually. And on the right-hand side, on the lower right-hand side, you can see where a project can be archived. If you're no longer being used or you want to archive it and later want to use that project, you can archive that project and then later can be retrieved or downloaded for that matter as a backup or as a copy of the project. But you can also delete them permanently if you're not interested in having that project any longer. You can permanently delete that project. So this is the first screen that you'll get to see when you log into the project or HAWQS system. Once you are in a HAWQS system, at the bottom of your screen you will also see a blue bar or blue button that says create a new project. In here you can either create a new project from the baseline, meaning the initial base model setup, and you can also create scenarios from that baseline model. So you have to have a baseline model before you can start scenarios in creating a scenario. How do you create a new project? For example, here all you'll be doing is you'll be basically zooming in and out of, just like on a Google map, how you normally zoom in and out. Actually, these are all based on a Google map. You can zoom into any rivers, any watersheds within the US, and you can simply click on the map. And when you click on the map, it will immediately show you where you clicked, and it will show you the green polygon that shows the watershed that you selected actually, and it also shows you all the neighboring watersheds plus the stream network. So when you hover over any of the sub-basin, when you click on any of the sub-basin, it will show you the HAWQS number, the 8-digit or a 10-digit or a 12-digit number. It shows you the area, the elevation, and the latitude, longitude coordinate of that particular sub-basin or particular watershed. In the future, we are also adding more features to this, where you can search, where you can simply provide a river stream network name or the river name or a county name or a zip code. Then it automatically searches and then allows you to select your own watershed. That could be either 8-digit or 10-digit or a 12-digit scale. In the next screen, I'm going to show you a similar selection that we did at Ruston in Mississippi River actually. So this is the entire upper Mississippi, all the way from Minnesota to Illinois, before the Missouri River comes and joins, for example. So that dark green that you see is the outlet that we selected. That's a HAWQS number 07110001. So when you selected that, it automatically selects all the water bodies or all the watersheds that are draining to that outlet. And that consists of about 92 subbasins and 28,000 HRUs. For those of you who are not familiar with SWOT, HRUs are Hydrological Response Unit, which is a unique combination of land use and soil and slope map within a subbasin. So HRUs are the basic building block in SWOT. So each landscape has got a unique soil, unique land use, and unique slope. You can also view the watershed routing. That means it can tell you how the watersheds are connected from top of the watershed to all the way to the outlet actually. Okay. So you have flexibility to either modify at this point, or you can simply use them if you want to use this as an outlet, or if you can move them, or you can select another outlet if you want to. So it has got lots of flexibility in how you want to select your watershed. Once you select the watershed, you basically give a name for your watershed that you are willing to store that as create as a project. And you can also check the box to receive email. So you don't have to be always logged onto the HAWQS system. Throughout the HAWQS system, you can check the box so that when the process is completed, it will send you an email that step is completed. Now you can proceed on to the next steps and follow the following steps and so on actually. Then there is also an advanced feature where if you want to, or if you want to change the routing, if you want to change how the subbasins are connected from one subbasin to another subbasin, you can modify that actually. But in general, we will not advise you to do that. But if there are any compelling reasons where you have to modify, you found an error and you want to adjust that, you have the option to change your watershed routing configuration within the HAWQS system. And finally, in the third step, you will be able to select whether you want to run an 8-digit or a 10-digit or a 12-digit resolution watershed actually. So the one I showed you, the 92 subbasins, is for the 8-digit because that's what the default it selects. But you can go back and modify that, so then you'll start to see the 12-digit basin map or a 10-digit basin map with number of subbasins and number of HRUs changed as per the selection. So the typical walkthrough in getting your project completed would be, once you have your basic project or basic watershed selected, as you see on the right hand side, then you have to select HRUs. So this is where you can take it from all the unique combination of hydrological response unit to the dominant or most appropriate or most probable configuration. I'll walk you through what I mean by that in the next slides. Then after you create the HRUs, you can modify your inputs the way you wanted it. I'll also walk you through all those input changes that we are going to talk about. Then you'll be able to execute the model directly on our website, or you can download on your local hard drive if you want to manipulate it locally. Once you've done the model, now you are allowed to able to create a scenario based on the baseline model that you already created. In the scenarios, you could run a climate change scenario, climate sensitivity scenario, or land use change scenario, point source change, fertilizer or urban landscape. So you have almost about 10 to 12 different scenarios that you can create, and this is the basic one that we have created so far, but we can also create more scenarios once you are able to provide us more input as a part of the stakeholder processor, actually as part of your input. You can also download your project. It can zip up the project and allow you to download. Then it also allows you to upload any related documents or provide us any feedback. So the report and tracking system is, if there is an error or if you want to have new features, you will be able to provide us direct input, and that input will directly come to us for further consideration. So once you set up your project, like I said, you can hover over the subbasins and get your HUC numbers or area and elevations. And it also provides you a metadata, actually. That means every stroke, keystrokes, or every changes you make in the project, everything's recorded, actually. So you can download later, let's say a month from now or 2 months from now, if you want to know all the changes that you made to your project, you'll be able to see every changes you made to your project from the base model to all the modification you made to create that project. And further, when you're doing scenarios, you will also be able to track all the changes you have made to the project, actually. Then you're also able to download throughout the interface. There will be this Excel symbol that you see that will allow you to download any subset of the data. Like, for example, here we are allowing you to download the mapping of how the watersheds are connected to each other, for example, or the number of HRUs, what are the HRUs, what are the areas, what are the land use. So you can be able to download all this information to your local hard drive to include in your report or to do further analysis with that, actually. But also it will be always saved in the HAWQS website, so anytime you want to go back and access them, it will be always available to you. How do you set up the HRUs? So as you can see on this top line, you can see the project and name of your project and HRU. So anytime you want to know where you are in the project steps, you'll be able to always go back to any of the previous menus. You can jump directly back to the project menu, or you can go back to the previous menu. So there is a kind of path that leads you to each step, and also it can allow you to backtrack to any previous steps that you want to go in this interface. Okay. The HRUs, like I said, in this particular watershed, about 351,000 square kilometers of 92 subbasins, we have about 28,000 HRUs. So you can adjust the HRUs based on either percentage or area, where using a slide bar, you can control how much minimum land use you want to consider, how much minimum soil you want to threshold you want to consider, or slope threshold you want to consider. So by doing that, it will automatically eliminate all those areas that below the threshold and keep only the dominant land use and dominant soil that you are interested in. So once you do that, it will provide you a diagram or a pie chart that shows you what was the finally selected. So you can see on the from the 28,523 HRUs, we are able to select around 2,978 based on the threshold we applied here. Actually, we applied 5% land use, 5% soil, and 5% slope. This is a very important step. If you make any changes at this point, you can review it, reset it, and redo it. Actually, once you set it, any future modification you do, you have to redo all the following steps, because this is our basic building block. Once you set this up, all your baseline model is set up. Any scenarios will be based on that setup of HRUs, it is not something that you can change in your scenario phase. Once you have done that, now you have to select what time period you want to simulate the model actually. The model is available, the weather data is available from 1961 to 2010. We are adding more data until 2015. In the next version, we will have up to 2015. But you can choose to run any time period between 1960 to 2010. And you can also set up your warm-up period or model setup period, whether that could be 2 years, 5 years. We typically recommend around 5 years actually, but it can be any time period that you want to set up. You also can select how you want to print your outputs, either daily or monthly or annual. The model will be always running on a daily time step, but you can choose to ask for the output at a monthly scale or annual scale or a daily scale. When you look at the output, some outputs are available only if they are printed on a daily time step. Not all outputs are available for all analysis. If you choose a different output, then you won't be able to see some of the features in the visualization tool. Later I'm going to show it to you. Then you'll be also able to show or select your model, which model you want, which version of the SWOT model you want to run. Any model upgrade that we make, we keep track of all the different versions, and thereby the user can choose. For example, if you build a model with the version 636 and then later 658 got released, then you would be able to go back and able to run that model actually, so that you always, it's backward compatible, and also you don't need to worry about all the changes in the input format and things like that. All those things are seamlessly handled by the HAWQS system. In this website, once you run the model or once you set up the model with the different inputs, where you see the lower left-hand corner, you see customized SWOT input data. So I'm going to show you various slides where I can show you how you can update your custom input data set actually for SWOT. It will not have the exhaustive list of all the SWOT parameters. This is what we thought is most important parameters for hydrology and water quality, but more can be added based on the user input. So this is where we need your participation and providing us feedback on that actually. Then on the right-hand side, there are various tasks that you can run, where you can write the SWOT input files, SWOT editor tables, or run the SWOT model directly on the SWOT website, on the HAWQS website, and finally you can process the SWOT output files. So all of them are in the scenario summary page, where you're able to have a dashboard where you can control the different settings. So next few slides, I'm going to show you what are the inputs that you can control. I won't be able to go through every one of them actually, so I'm going to hit the highlights, but once you start logging in, you will yourself be able to see the list of input that you can change. This is the basin input. This is for the entire watershed input, where we provide you what is currently used in the model and what is the range, valid range based on the SWOT literature, and we also provide you what is the default that model uses actually. So you have the default. If you don't change anything, the default is what's used, and the value is what you can modify to change any input that you want to change in this model. Every interface or every screen I'm going to show you hereafter always will have the valid range and the default value as a guidance for you actually, but the value is what's actually used by the model. And every time you make any changes, you have to come and click on the Save Changes button at the end of the screen, or at the bottom of the screen, and that's recorded in your metadata, and that's kept track on every step of the way. Here is another input. Here we are customizing the fertilizer input, where you can customize what is the organic matter, organic nitrogen and organic phosphorus in a, for example, in a beef, or in a beef manure, or a chicken litter, or hog manure, or whatever it may be. Actually, you can control the concentration of nutrients in the per unit or per kilogram of fertilizer. Thereby, when you apply this fertilizer, that's converted into the amount of nutrients goes into the soil. So you have total flexibility of controlling the manure application and the fertilizer application. You can also control the nutrient efficiency factor actually. So by default, it's assumed as 1.0 efficiency. That means everything is applied close to the field. But you can change the fertilizer efficiency by increasing or decreasing. What happens if you put only 70% of the crop required? That's going to change your water quality, for example. Or what happens if the farmers put more than 100% required by the plant? So you can adjust the nutrient efficiency and look at the impact of that in terms of water quality or non-point source pollution per se. Similar manner, you also can customize the urban data. Here we talk about the impervious and pervious cover, and also the different coefficient that used for nitrogen and phosphorus export from an urban landscape. Those can be customized, and you may be able to run different scenarios based on that. What happens if the urban sprawl is controlled and you have more pervious versus impervious, or what happens if you have a porous pavement, or what happens if you have a green infrastructures and things like that. So you can modify those custom inputs and be able to run scenarios based on that actually. Here is a screen where you can update land use. Okay, we give you a sample input of what the current land uses are. Then you can say what happens if that land use changed from X to Y. What happens if agriculture changed to rangeland, or rangeland change it to a urban landscape, or whatever it may be actually. So you can change this as many number of times as you want throughout your simulation. Thereby you can run the model on a more dynamic land use update when running the SWOT or the HAWQS system, for example. And it also comes up with all the input-output document that's required to customize that input. And we also provide you a lot of example files for that actually. Here is another screen for climate change. We have currently incorporated 9 different climate change models of CMIP3. We are working with Office of ORD, Office of Research and Development, and others to add CMIP5 of 5 different models. So in the near future, we will have CMIP5 also. And here you will be able to select your model, select the time period you want to simulate in the future. Also, you can be able to select the different scenarios and be able to compare between the baseline and the climate change scenarios. Here is another input screen where you can change the climate sensitivity or climate variability, where you could say, okay, what happens if I want to change, say, temperature data or precipitation data, delta change in temperature or percentage change in precipitation, but you don't want to apply to all the subbasins. Let's say I want to apply to a specific subbasins. That's where you're selecting specific subbasins on the left-hand side and specific months. So you may say, what happens if the temperature gets warmer in the north and the rainfall decreases actually, how that impacts the snow cover and snow melt and snow pack and so on and so forth actually. So you can run easily a quick sensitivity or variables, the climate variability analysis, and look at the impact of that on the watershed, both on water quantity and quality. Here is another screen where we talk about weather generator. One of the key input in SWOT is the weather generator, where you could come and say, what happens if the rainfall intensity as it's climbed in the weather in the climate change world, the future climate is going to have more intense rainfall, short duration, but with very high intensity. So one can change this intensity, either increase or decrease that actually to all subbasins or selected subbasins, and be able to run the impact of higher intensity and what that's going to do to sediment or water quality and water quantity, for example. Here is another example of one input, which is the curve number. Curve number is the hydrology equation used in SWOT, and here you can say how you want to adjust the curve number and whether you want to apply to only all the subbasins or only selected HRUs. So there you can select the subbasin and the land use and the soil and the slope where you want to apply these changes and be able to customize your curve number values. Okay. So when you modify, you can have an incremental. You could say, I want it for forest land and on these soils, or you can come back and say, I want to in one form you could be increasing curve number for the forest. In another, you may be decreasing curve number for different land use, for example, or different subbasins and so on. So you have total control on how specifically or how widely you want to make changes to your inputs, and you'll be able to keep track of all the input changes that you're doing within the HAWQS system. Here is another input where you can control the sediment routing. In SWOT, in the most recent version of the SWOT, we have 5 different equations that you can choose from for sediment routing in the rivers or in the channel. So one can choose, and we have the documentation of all the 5 different algorithms, how that may affect your model output and so on and so forth. And you can apply those equations to any specific subbasins or to all subbasins. So that gives you a kind of all the input changes that you can do, and this is one of the last input change is the point source. So in SWOT, you can input point sources either a constant, daily, monthly, or annual. So annual means it changes from one year to another year, but within the year it's a constant. If it is a monthly, it changes from month to month, but within that month it's a constant. If it is a daily, every day it changes. Or if you say it's a constant, that means every day throughout your simulation, it's a constant value, such as how much is the flow, how much is sediment, nitrogen, phosphorus, organic form, inorganic form, pesticides. All those things can be input in the model. Currently, we do have default point sources. However, this came from a national databases actually. So there are more accurate or more detailed information at the local level that you may have, that you may want to substitute that with what we have. So this menu will allow you to input your own point source data, or you want to run a scenario, you can use the same menu to run future scenarios if the population growth increases and how that's going to impact some other point sources and stuff like that. All the inputs are only a CSV, and there is a complete guidance and documents and example files are provided that user can download and be able to make the modification and then upload them, and that will be run as a scenario within HAWQS system. Okay. Once you made all the changes that you want, you can also customize your output. For example, there are 3 basic outputs you get from HAWQS. HRU level, which is the most detailed output. Then we provide you at the subbasin level, and then the reach level. Reach level means at the river. Okay, so you can customize up to 20 variables you can choose. SWOT provides almost about 60 different variable outputs. Actually, you can choose out of the 60 which are the 20 you want. By default, everything is selected, so you'll get all the 60 of them actually. However, if you want to be very specific, or you don't want to analyze, let's say you're not interested in pesticide, so you don't need all those pesticide output, you can customize what output you want and where you want. In the next screen, I'm going to show you which HRU you want. It's not only what variable you want, and also what spatial locations that you want that output can be customized. So for it's 20 up to 20 variables or 20 locations you can control in the current system. Once you selected that, now you can write the SWOT input files, and if you are going to download the data and use it with SWOT editor program, then you can write the SWOT editor table. Otherwise, you can bypass that step. If you're going to do everything on HAWQS website, you don't need this step actually. Then you can run the model. Before running the model, you can always click on this time estimate. It will give you a quick, based on the current load, based on the number of HRUs, the number of subbasins, the number of all your parameters that you selected for your base model. It will give you whether it's going to take a few minutes, or it's going to take an hour, or it's going to take 10 hours. So it will give you the time it requires to run the model, and you can check this receive email notification. Thereby you will get a notification when that process is complete. But anytime you come back and log in, it will still show you where it stands. So it will give you the updated log status of that current operation in terms of how much more time is required and whatnot actually. Then the last step would be processing your output files. So all of them can be run on the HAWQS website without needing any local computational power. All you would be needing is a web browser to do all these tasks. Once you've done that, the model will give you some candid reports, standardized reports actually, and then it'll allow you to further customize those reports or tables or figures by yourself actually. So the first output will be the summary chart. I'm going to just show you the next few slides on different output that you can get from the HAWQS, but more outputs are getting added to this in terms of including map generation, comparing different scenarios and things like that. So those are all work in progress, and we will be continuing to improve that output sections of this interface. So here it gives you the summary output based on whatever the period of time period that you run the model, what is the monthly hydrological budget. So the first top left-hand side, it shows you how much is the snowfall, how much is runoff, lateral flow, groundwater flow, ET, and so on. On the lower right-hand side corner, it shows you the sediment distribution by month actually, which month is producing most of the sediment, for example. And on the top right-hand side corner, it gives you the total budget, meaning how much is the rainfall. Of that rainfall, what percent is evapotranspiration, what percent is stream flow, and what percent is runoff, and so on and so forth actually. So it gives you a quick snapshot of the overall water budget and sediment budget for the watershed. Then it allows you to customize your output for any specific reach. Currently, we have these 6 options to plot your output. Load duration or flow duration curve. Again, it's one of the most requested by most of the stakeholders or most of the users, that they would like to have a load duration curve or flow duration curve generated automatically by that could be used directly in their TMDL analysis and other water quality analysis. Or you can look at the daily average or monthly average or annual average, or you can ask for only what is the maximum of certain constituents, whether it's a flow or sediment or nitrogen or whatever, by month or by year or whatever the time scale step they want, or what is the minimum, for example. Or you can also get exceedance. How many days do I exceed this water quality threshold? Let's say if you're going to be doing a nitrate concentration in the river, and you can say, well, how many times I'm violating the standard of 10 parts per million, for example, then it will tell you how many days in a month you are exceeding that particular limit. Then sometimes you can also get percentile. So if you want to look at the percentile of flow or percentile of concentration of say, nutrients over a time period, you can also get that actually. So there are many ways you can analyze the data. Some of these are available only if you run the model on a daily time step. Some of them are available for daily, monthly, and annual time step. So once you select whatever the analysis that you want to perform, you can select the variable that you want to perform on and the location, because if you're doing a watershed like Mississippi, you have 92 subbasins, so you can choose any one of those subbasins. Wherever along the river you want to do the analysis, you will be able to perform that. So once you download that, you can download the data as a raw data as a CSV format that you can do it as a local, or you can just say process my data and you want to analyze the data on the HAWQS website. You will be able to do that. This one I'm showing you right now is flow duration curve. So one could look at easily at 20% of the time the flow is going to be at least 20 meter cube per, sorry, at least 176 meter cube per second or above actually. Okay, so that means remaining 80% of the time your flow is less than 176 meter cube per second. So you can do the same thing for water quality as a load duration curve. You can have multiple curves also, so you don't have to limit to only one variable at a time actually. You can do a flow and a sediment, for example, or you can do a flow and nitrate and water quality. So you can do multiple variables and looking at that. And all these outputs can be stored, as you can see on the top right side there, you can store as an image, or you can directly print it, or you can save it to your local hard drive and use it with your PowerPoint or Excel and so on and so forth actually. Here is another graph that shows you the time series. This is from 1963 to 65. On the left-hand side, it's a flow. and the right-hand side is the water temperature, for example. So you can have variables at different scales. You may be able to show them actually, and you can also zoom in and out of any of this variable by using a pinch chart, meaning you can just draw a box so it will zoom into that particular area. So if you have data for daily and that's so crowded, and when you're looking at a 5 years or 20 years or 30 years output, you can zoom in and out of any of those for any critical time period or critical season that you want to look at those outputs. In HAWQS, we have also incorporated the SWOT check program. Those of you who are familiar with SWOT would know what SWOT check is. SWOT check is a way to diagnose your results on any potential input problems or any potential model problems, or looking at the overall analysis. So this helps you to look at a quick snapshot of how much of my rainfall is converted into snowfall, how much is converted into evapotranspiration, or how much as a direct runoff versus lateral flow versus groundwater flow. So all those things will be given as a quick snapshot, not only for the hydrology. You can also do the same thing for sediment, nitrogen cycle, phosphorus cycles, plant growth, nutrient losses, both in surface and subsurface and groundwater, land use summary, in-stream process, and so on. So SWOT check gives you various ways to diagnose your model input and model outputs and look for any potential problems, or have a quick analysis of where the sources of, for example, if you're going to do a TMDL analysis, you need to do the source load allocation, for example. So this would give you a quick snapshot to provide where the sources are coming from, what land uses, and where the what subbasins and where they are coming from could be quickly analyzed with SWOT check. As I mentioned to you previously, once you click on the metadata, it keeps track of every input changes, every output that you analyzed. And here is an example of that screen. I was not able to capture everything that was changed in this project. I just give you a brief snapshot of that actually, but this may be multiple pages and very long, depending on how many changes and what inputs you modified and whatnot actually. But the nice thing is this could be something you can download it, and thereby you can keep track as a part of your project project inputs of all the changes that you made, so that you don't need to guess what you did 2 months from now or 10 days from now. HAWQS is being calibrated where we have the data, almost about 100 different locations we chose at the 8-digit watershed outlet for monthly flow, sediment, total phosphorus, and total nitrogen at the 8-digit watershed. Then whatever the parameter that got calibrated at the 8-digit level got propagated to the 10 and 12-digit watersheds also. And as you all very well know, those who are modelers, calibration is a continuous process, and we try, as we get more data, more locations, we wanted to improve the model and make the model as a living, continuously improving system. However, we are also planning to use like a crowdsourcing, actually using the users as they use the system. If they find a better way to calibrate, or if they have a better source of data to calibrate, we would like to hear from you so that we can incorporate those changes into the HAWQS. So it's a two-way communication. It's not just a HAWQS as a modeling tool that you could use, but we also can benefit from your usage by submitting your feedback to us actually. With that, I'm going to stop and ask for a full question, right, at this point.
Yeah, what's the next slide?
It's the use case study.
Yeah, so before we jump into the use case, I think what we'd like to do is, Arndt's been very efficient here. Arndt Gossel's a member of our team, and he's been answering most questions as they come in. But we flagged a few questions here for Dr. Srinivasan. And again, we're going to try to answer them here. If we can't, we can certainly follow up. All these questions get logged in, and we can add them as FAQs later. But let's start with the, do you want to select the questions? Start with the first one?
You can read it.
Let me read the question. Okay, there's for NHD+, what is the scale/resolution of the reduced form?
Okay, for the 12-digit, we used the NHD plus. For the 8-digit, we used the RF1 actually, but we compared the RF1, which is, I know Richard Alexander is the one asking that question, and it's the same as what Sparrow has been using for national modeling. So we use the RF1 for the 8-digit, but 10 and 12-digit we use the NHD plus, and we took the main routing river that connects between two 8-digit, two 10-digit or two 12-digits is what was used in the for the routing connection and routing length and routing parameters in the model.
Okay, great. So let's move to the next one, and let's take this one. If you run a baseline simulation in HAWQS and then want to export results to modify and run on your own computer in SWAT, do you need to have the same version of SWAT on your computer as is being used by HAWQS?
Yes, but when you export the model from the HAWQS, you will also get the executable of the SWAT that you could use in your SWAT editor actually. So I don't think you will have any problem in executing the HAWQS version of the SWAT, and that same version will be also exported to your local hard drive. Thereby you will be able to do the same thing actually.
All right. Can we create a project using user-defined watersheds?
Not at this time. Right now, in order for the three spatial resolution, the 8 and 10 and 12 digits are what's available, but we are having an internal discussion about possibly adding NHD plus watershed, not at the current level of NHD plus, maybe a modified and aggregated NHD plus watershed that may be somewhere between 1 to 10 square mile as an average size. Right now, our 12-digit watershed is an average size of about 30 to 50 square miles actually. So we will have another version or another data set, spatial data set that user could choose somewhere around 1 to 10 square mile actually. So that's something in the planning stage. It's not fully thought out or fully explored.
Great. Let's take one more here. There is can water withdrawals for public supply, for example, be represented and simulated in HAWQS? And if so, to what temporal resolution, annual or monthly?
It can be daily, monthly, or annual, because in SWAT, the water use data, there are two ways you can input water use data actually. One is through the point source. So if you have a positive number in your point source, that means you are adding water to the river. If you put a negative number, you are removing the water. So if you are removing water from the reservoir or from a river, you can represent that as a negative number actually. But if you want to add a point source, you can also add actually as a return flow. Maybe you are taking water from one part of the river and returning to another part of the river. So where it could be a negative number where you're removing water, and wherever you are adding that water as a return flow from the point sources, you can put that as a positive number. So you can, yes, you can modify that, or you can incorporate that at any temporal resolution, daily, monthly, or annual times.
Okay, here's a climate change question. How does HAWQS fill in data gaps from the stations included in the climate database?
Currently, we took all the, approximately there are about 18,000 climate stations in the US, the NCDC, the NOAA site. So we interpolated all those things using a Thiessen polygon and then overlaid the 8-digit, 10-digit, and 12-digit watershed and aggregated that weather data. Currently, we are also allowing, or we are also processing NextRad, PRISM, and additional NC/DC stations. So in the near future, like version 1, when Praveen was talking about the future release, we will have the data at that's come from the NextRad, which is a 4 kilometer, 4 kilometer. Prism is also a 4 kilometer, 4 kilometer product, plus the NC/DC data set. So you'll have about 3 or 4 different weather input data set that you can choose from to run your baseline model, and any future climate change scenario you want to run, you will have the climate change models also. CMIP3 and CMIP5 will be available to choose from.
Okay, one last question, and again, we're going to come back to questions later on as well, but this one may have been partially answered. Would this platform be useful to national users for basins outside the United States?
The platform, absolutely yes. We have one of the things that we wanted to have is we also have another identical version of this called HAWQS, which is called hawqs.tamu.edu, which is exactly the same version of the HAWQS, and there we are going to allow any international users want to submit their project and want to upload that, thereby they can want to share their projects or their watershed modeling experience with others. We would be able to do that actually, but if anybody wants to use this platform and want to launch their own application internationally, that's also quite possible actually. So it's not everything what we did here is all public domain, both the technology and the tools and the data sets, whatever that we used. So I think the platform itself very nicely lent to do any place in the world actually if you choose to do that.
All right, let's take one more question actually here. There's a question from California here. Let's see here. See it? Yeah, it says, if I have a watershed in California that has not been calibrated, do I need to calibrate the model first? If so, how do I use HAWQS for calibration?
Okay, that's a very, very good question actually. So that's because we calibrated only about 100 locations. You can see that California, there is only about 2 sites or 3 sites is what we have done. Is most of them are in Sacramento Valley region, but not anything in the lower part of the California. Yes, if you want to do that for anything like a TMDL analysis, you have to. But if you're going to run the model like a climate change scenario, for example, or any kind of scenarios where you're looking at the output as a relative difference between a baseline and a change and a scenario, you may not need to do the calibration because SWOT is fairly well tested in many, many places actually, whereby you can look at the percentage of change from the baseline to a scenario. That means whether the nitrogen increased by 5% or 10% in the river and whatnot, you can do that as a percentage change. But if you want to use the actual number, if you say my load reduction strategy is I need to reduce 100 kilograms per hectare of nitrogen in this watershed, then you got to have some amount of calibration to gain confidence in the model before you start using that model for a TMDL type of applications. So it depends on what applications you are trying to do, whether calibration is required or not required, but calibration will be always advised if it's possible, and if you have the data to do that, we will always advise you to do calibration. And that's where you can download the whole data into your local hard drive, and you'll have the entire tool set for the SWOT to do offline calibration and manipulation and running any kind of scenarios you want to do.
All right, great. So let's jump into our case study,
okay,
and then we'll come back to questions again at the later part of the webcast.
Okay. So the next few slides, I'm just going to walk through one case study. So far, all I've shown you is all the capabilities, all the screenshots, and just to walk you through all the features that's available within HAWQS. Now I want you to go through one specific use case or case study. So in this case, we looked at a river basin called Maumee River. Most of you may be familiar with this. Actually, this is a river that flows into the Great Lakes. And in this river, we just looked at the 8-digit level actually. This dark green that you see is the outlet of the basin before it reaches the Great Lakes, and it consists of about 7-8 digits above that actually, with about almost 1900 HRUs in this 8 digits, 7-8 digits. So we set up the model for this Maumee River basin, and we set up the baseline condition for the Maumee River, and then we set the HRUs. For example, the next step after setting up the basin, we had to set up the HRUs, and here are the HRUs. We set up a 5% land use and 5% soil and 5% slope, and that reduced the number of HRUs from 1800 to only about 280 actually. So I know this is very difficult to read this slide here actually because there are too much information on this slide. On the left-hand side is after you apply the threshold, how the land use is distributed. On the right-hand side, it shows you before you apply the threshold of HRUs where it is distributed. And also it gives you the table. All of them can be downloaded and can be printed and can be saved into your local hard drive if you want to further manipulate this actually. Again, this is just an example to show you this. We selected the Maumee Basin with a 5% threshold on land use and soil and slope. Once we've done that, now we selected the model to run from 1981 to 2000 with a 5-year as a warm-up period. So that's about 15 years worth of model run, and then we selected a monthly output. Okay, so this is our baseline model run, and we went through and run the model, write the inputs, run the model, and process the SWOT output. I'm going to show you some of the outputs in the next few slides. I'm also going to show you what scenario we ran, and the climate change scenario we ran actually. Let me skip this slide. This is just a visualization. So for this climate change scenario, we used the Canadian climate change model version 3.1 with a future scenario of 2081 to 2100. So basically 1980 to 2000 is the one scenario, the baseline scenario. The future scenario of the Canadian model is 2081 to 2100, and the scenario itself is A1B. This is CMIP 3, and like I mentioned, CMIP 5 is we're still processing it, and hopefully sooner we will be able to do that also. So with the same 5 years warm-up period, we ran both the baseline model and the climate change model. So between the baseline and the climate change, it's just only one screen. You need to modify your climate change scenarios, and then you can click and run the model. So at the maximum, you'll be clicking about 3 or 4 screens to baseline setup model, then 1 or 2 screens to run your scenario. So it'll be very, very quick to set up a baseline model and a scenario model within the HAWQS system. Once you run that, you'll be able to look at things like load duration curve, for example, flow duration curve. So in this case, the left x-axis is the time or percentage of exceedance, and the y-axis is the flow. So this is the baseline model. The top one is the baseline model. The bottom one is the climate change model. So you can see around the 99th percentile, there is a steep increase in precipitation due to that steep increase in runoff or stream flow. So if you look at the scale, the baseline model goes from 0 to 800. The climate change model goes from 0 to almost 1500 actually, almost double. So, but most of them are happening at the 99th percentile or 98th percentile and above actually. So that gives you a quick way to analyze if the climate change is really true in this Maumee Basin, how that's going to accelerate the nutrients or the sediment or the flow that may be leading into the Great Lakes, for example. Another one is you can also look at the SWOT check here actually. So here I'm showing you, I know it may be difficult to read, it's basically 33% in the baseline model, 33% of your rainfall is stream flow. Your evapotranspiration is 63% actually. Whereas under the climate change, we are seeing almost 41% is stream flow and only 56% is your ET. Because of the high intensity in rainfall, most of them are going as a runoff, then less is going to soil, thereby less is available for evapotranspiration. So there are many, many ways for you to analyze, like example of scenario in this case is climate change, but this could be land use change, it could be point source change, or it could be urban landscape change. So there are many, many use case examples one can analyze. We are also developing a document of various use cases, and those documents will soon be available through the HAWQS website. Thereby, if you want to have an example of how do I change point source, I want to run a point source scenario or a land use change scenario, how to do that, we will have an example document, an example data set to walk through step by step on how would you do your own use case studies, for example. I'm transitioning now from a use case to where are we heading next actually. In the HAWQS, we are continuously identifying and engaging various users to improve the HAWQS system actually. So it's continuously modifying, continuously improved based on either user interface or data sets, and various things are planned which I already alluded in climate data sets and climate change data sets and so on and so forth. We are also enhancing the HAWQS user experience, so the HAWQS screenshots and the interfaces, adding a lot of documentations. And we are certainly need to do a lot better job in our output visualization tool, including the mapping the results, comparing multiple scenarios for a project, and so on. And we already mentioned that we are also working on enhancing collaborative project where one person could be developing a project or multiple people could be analyzing those outputs or running the model or running different scenarios based on one baseline model and things like that. So the multi-user level of project collaborative sharing and collaborative modeling is something that we are planning in the near future. We will be adding the CMIP5 data sets, as well as we are planning to improve the water temperature model that's in SWOT. There are already a few publications have been published on improved water temperature model. There's a great interest on that, so we will be adding those new capabilities. And we are also continuously looking for ways to improve the atmospheric deposition and point source data set. Both of them are national input at this point, but as we get more refined input from the state and other sources, we would like to improve that actually. Right now, the soils that we are using in HAWQS is a STATSCO, State Soil Survey Map. We would like to improve that with SURGO Soil Survey Map actually, because SURGO is not available everywhere in the US, especially in Indian reservations and other places. So we may have to substitute in those places with STATSCO, but that's something is planned. And finally, we are also going to be adding the SWOT CUP uncertainty analysis. Those who are familiar with SWOT CUP, which is a CUP stands for Calibration and Uncertainty Program, we will be adding an uncertainty module so that when you're running the simulations, you can run the parameter uncertainty analysis with SWOT and be able to provide not only just the model output, but also the uncertainty on the model output estimates will also be able to be captured through this process. And that gives you a glimpse of what else we are heading, where we are heading, and what we are planning to work on. At this point, I'll ask Praveen to.
Yeah, I think we have a poll question coming up. So Laura, if you'll.
Sure. All right. Our last poll, based on what you know about HAWQS now, do you envision using HAWQS to support any current or future water quality monitoring work? And again, we'll give you a little bit of time to respond, and then we'll share the results. Okay, well, it looks like most of you are open and considering it. maybe you'll be using it, or you're not sure, and over a quarter of you are affirmative, yes, you will be using HAWQS for future water quality modeling work. Good to know. Thank you for sharing.
All right, great. So I think, we ended early. This is our first webcast, and, we thought 68 slides would maybe take longer, so perhaps we need to adjust that a bit, but there's still a lot of excellent questions that have come in, and we're going to spend some more time answering them. And again, our goal is to go through all of these questions after the webcast, and then have written responses, which we want to turn into an FAQ on our website, and also in the user guide. So let's just start off with this question here. Can the user pick HRUs without specifying percentages of the different parameters, e.g. slopes?
Yes, you can protect actually in just like in ARC-SWOT or Q-SWOT, you can say that you want to exempt a particular HRU from getting deleted or getting reorganized because of the percentages that you may choose actually. So you can say that, for example, wetland, you want to model a wetland regardless of how small it is, for example. That means you can exempt a particular land use, thereby it will not be left out. But again, if you don't want to leave anything, you can leave them as 0, 0, 0. That means every HRU will be considered for the modeling. You are not required to go through the HRU step if you don't want to actually.
All right, great. The second one is, are you concerned about the validity of the Maumee River model output scenario analysis if subsurface tile drainage is not incorporated into HAWQS?
Subsurface tile drainage is incorporated in HAWQS at the national scale. I know Charles is from Iowa and he's got a lot more detailed data there actually, but we would be able to add any additional details to any local information that's available. But right now, based on the StatsCo soils, wherever there is a poorly drained soil and agricultural land, we do have automated the tile drain system in most of the watersheds actually. So at least in the Maumee Basin, we do have tiles, and also most of the Iowa.
Great. Then can you briefly explain the crop management inputs that are available in HAWQS? Tillage, irrigation, filter strips, other BMPs?
Okay. The current HAWQS, we are using a national database from NRCS called Russell 2. It is collected from the farmers on county by county actually, and then aggregated to what they call crop reporting regions. So we use the crop reporting region land management data by land use, by soil, by slope, and then we take that information and then populated that for the HAWQS for each 8-digit and 10-digit. So we converted from the county to a crop region to 8-digit and 10-digit and 12-digit. There are certain issues when you're doing that type of extrapolations, but that's the best we have at the national scale for us to do analysis at this time.
Okay, let's take this other one. Let's take this one. What does the daily time step output report for DO? Are the min, max, and average the ones from a diurnal curve?
No, right now just the daily mean is all we are reporting at this point. SWOT is still a daily time step model, so our output is going to be just a daily mean, even though the diurnal calculations are done, but the output will be only as a daily mean.
All right. Another question. How do you convert HAWQS output to fine-grained model like HSPF?
HAWQS output to, I mean, you mean, is it spatial or temporal? I think we are talking about temporal or sub-daily time step, not the HAWQS, but you can still use all the HAWQS input to develop a baseline model and that you can download, and at the local hard drive, you could still run at a sub-daily time step if you have the weather data at the sub-daily. Because the HAWQS is going to give you only daily input of weather inputs and all the land use and soils and so on and so forth. But if you want to run at a sub-daily time step, you have to supplement that with your own sub-daily data. Then the model would be able to run at sub-daily time step of hydrology and sediment and so on.
Okay. Can the model output individual point source loads, or are they lumped per sub-basin?
They are lumped by sub-basin, that's true, because currently you can have one point source per sub-basin. So if you have multiple point sources within the same sub-basin, for example, in an 8-digit, they are all lumped together as one point source in the model at this point.
And yes, that's a feature we're going to be looking at closely for the next iteration and the next release. So that's one of the priority items we're going to be pursuing. Right now, I think we're going to move into a live demo. You said, Dr. Srinivasan?
Sure.
Did you want to demo something related to the point source, I believe?
Yeah, we can do that. Actually.
Yeah, let's do a live demo for a few minutes, and then we can jump back into some final questions.
Hope all of you are able to see the screen, and let me walk you through how to create a new project, all the way from creating a new project. So when you log in, this is what you're going to see, and you may not have any projects because I already have a couple of projects generated here actually, but otherwise you'll be simply selecting create a new project. Okay, so that's going to bring in this US outline map, and you can zoom in to any location that you are interested in, for example. So I'm a little familiar with Texas, so I'm going to go and select something in Texas. So, okay. So for example, here is a lake that I want to model this lake, for example. So I can simply click on that area. So it automatically selects that as my sub-basin and all the surrounding sub-basins. So as I hover over, you can see what is the HUC number and what is the area and the elevation, the latitude, longitude of each of the basins. So if you want to change it, I can simply click on another basin. Like for example, it also shows you what is the river name actually. So when I move my cursor to the river, it will tell you it's a Trinity River, for example. Oops. It's, yeah, like here. Okay. So if I want to model the entire Trinity, I could have chosen say entire Trinity. So that's going to select all of the Trinity, for example. So this is the entire Trinity River. So the user can choose any interactively any watershed that they are interested in. Then you have the option to choose whether you want to run at an 8-digit, 10-digit, or a 12-digit actually. Okay. So if you're going to model the entire Trinity, 8-digit makes sense. But if I'm going to model just say one tributary, for example, one basin, like this is a Richland Creek, okay, and then I could say, sorry. Right. Okay, there it is. So, like I said, you can do 8 or 10 or 12. If you want to do a 10-digit, you just simply select 10-digit. It's going to reload all the 10-digit map now. So now you can see how many 10 digits are there. If you want to go to a 12-digit, you can also select 12-digit, for example. Okay. So depending on what you select, it may be able to select more than one, for example. Or you can even select downstream HAWQ by directly, you can type in the number. So once you've done that, let's say you want to model this basin. This is a little bit larger basin. There are 11 sub-basins with almost 3,000 HRUs in this watershed. And you can look at the watershed routing information, how they are connected together. Then you say click create a project. So it takes about a few minutes to create your project actually. So once the project is generated, then you'll be able to customize your input. So you selected your basin, and now I'm going to set my HRUs. So here again, it gives you all the different land use percentages. So if you move your cursor, it will tell you what each land use it is actually. For example, urban high density or winter wheat, forest, and so on and so forth. If you want to protect any of these land uses, for example, urban high density is very important. I can go and check this box. When I check this box, that particular land use is exempt. That means regardless of how small that land use is, it will be protected, and thereby it will not be subject to any elimination from the HRU calculation. Again, if you don't want to use percentage, you can also use area here actually. You can say don't consider any area that is less than 100 hectares or 50 hectares or whatever that you want to specify. Okay. Otherwise, you can just put percentage. Again, just for a case. So I'm going to just use the same 5%. 5% land use, soil, and slope. And I can say set my HRUs. So right now it's going to our table of 3,000, almost 3,000 HRUs, and it's going to subset from that based on the 5 and 5 and 5. It's going to come back and it's going to tell you there are 491 HRUs. You can download exactly what HRU was originally there and what HRU was selected after applying the threshold. And it also gives you the distribution of your land use after you apply the threshold and before you apply the threshold. All these things can be downloaded and printed and saved on your hard drive or PowerPoint presentation and things of that nature. Or you can even change the chart type from pie chart to bar graph and things like that. And here it gives you what is original land use and what is after a threshold is applied, how much of that land use got converted and stuff like that. It's going to give you all the details actually. So once you're done that, once you're happy with that, or you can change it right now. You can reset and go back and redo this analysis as many number of times as you want. But if you are satisfied with that, actually, you can review all of these inputs, and then you can go back to your watershed. Okay, and now we are ready to create a scenario. So once your HRE is completed, now I can create a scenario. So this is my baseline default scenario. You can rename anything you want, and you can select what are the time period you want to select. Okay, until 2010 we have the data for. Because of the time, I want to keep it small, like 5-year simulation with 2 years as a warm-up period. So you can see every time I hover over any of the screen, you have additional help messages in there actually. And you can get daily output or monthly output or annual output. So you can choose the output daily, or monthly, or annual. And then say create your project. So now it's created your project, and you can now start to customize your data, like basin input, fertilizer input, nutrient efficiency. These are the screens that I showed you before that you can customize it. For example, curve number. Let's say I want to increase my curve number by 2% or 5%, whatever number may be. You can apply it to all HRUs, or you can apply it to only selected HRU or specific HRU, meaning specific sub-basin, specific land use, and specific soil, and so on and so forth. Okay. And once you do that, you simply say save changes. So it keeps track of all the changes that you made. So here it keeps that information, and that goes into your metadata. So once you're done all the changes that you want to do, you can now go back and you say, I'm ready to write my input file, and I'm not going to download the data, so I don't need to write the SWOT editor. I want to run the model, and I want to process my output. And if you want to receive my email, I can also ask for receive email. So I'm going to click Run Selected Task. Now everything is running on the Texas A&M cloud computing environment actually, where all the changes, all the things that we just now submitted for a specific watershed, in this case, entire Trinity River Basin, is being extracted and running actually. So you can already see how much time it's going to take to do this, and it's already finished running the model, and it's reading the output at this point. So it's done. So you can see how much time it took to set up a model from start to finish, for example. And this is a very sizable watershed. It's approximately, I think it's 11,000 square kilometer watershed. So at this point, I can look at summary output. For example, quickly I can look at the summary output of what the hydrology and what the lateral flow, what the surface runoff and water yield and so on. It's Texas, so we don't get much groundwater. So, and here is the sediment. So you can see which month is contributing most of the sediment in this watershed. And then here it gives you the water budget. Again, this is the summary of all the years of simulation, that is 1963 to 1965 monthly average. Or I can go back and I can ask for example, SWOT check. Okay. So here I can look at the simulation details. We ran the model for 5 years with a 2-year warm-up period. There are 491 HRUs with a daily output with 11 subbasins. And here is the hydrology. So you can see only 17% or 17.5% of your rainfall is runoff. And almost 72 or 73% of your rainfall is evapotranspiration. Of that 17.5%, only 2% is base flow. So base flow is very little here. So it also gives you the important components of your hydrology. How much is your rainfall? How much is your ET? How much is your potential ET? The average curve number used by the model, and the runoff, and so on and so forth actually. And you can also look at things like sediment, where the sediment is coming from. For example, it shows you the landscape. It's producing about 0.23 tons per hectare. Megagram per hectare means tons per hectare. And because there is a lot of lakes in the river, so almost 2.5 tons is getting deposited. That's why you're seeing a negative number. That means a lot of dams along the river is getting, a lot of this sediment is getting stored in those dams or reservoirs. Then you can look at nitrogen cycle, phosphorus cycle, or you can look at the land use summary. Like by each land use by land use, you can look at how much is the precipitation, how much is the runoff, groundwater. So this is kind of a source water contribution actually, and also the pathway of how the sediment moves and how the nitrogen moves and how the phosphorus moves and so on and so forth can be easily obtained. All these things can be simply right click and you can save it and copy and paste it in Excel, and you can do more analysis with that if you need to export this data. In the interest of the time, I'm going to move back to showing you the output, one more output, which is the reach output. So here you can choose load duration, flow duration, or exceedance curve, and so on and so forth. Let's say you want to look at flow and sediment, load duration curve, okay? And you can choose any locations in the watershed, okay? So let me select the watershed outlet, and I say request my statistics, and then process the data. So at this point, it's processing the daily output for the 3 years at that watershed outlet, and then it's going to now allow you to chart those output, for example. So here is your flow duration curve, okay? Probability of exceedance. So you can see at least 20% of 190 meter cube per second or above is 20% of the time actually. Or if you want to look at sediment, you can look at sediment also. So you can look at sediment on the second y-axis and the flow on this axis. So you can see where the sediment and flow. Okay. So you can have multiple plots. You can change line graph to bar graph and the other graphs also here actually. So there's a lot of options here to change your outputs. Are we okay on time? Okay. So that's the baseline model. Let's say you done the analysis of the baseline. So now you can come back and now you can create a scenario based on this baseline. So you could say, okay, I want to create a scenario here, and you can give a name for your scenario. Let's say climate sensitivity or something like that. For the same time period, you want to change something, let's say. So now you can choose what do you want to customize here actually. Let's say I want to change the climate. Let's say I want to change my rainfall by increase the rainfall by 12% and increase my temperature by 2 degrees, let's say. Okay. So what is that going to do? Whether you can do it for all subbasins or you can select your subbasins. Like you can say, I want to apply this to only to selected subbasins. Okay. So subbasin number, let's say these two. And you can also apply to only the specific months. The temperature is going to increase or the rainfall is going to increase. So you can select all of them or you can select all months. Okay. So depending on what's your interest, you can select all or specific months actually. For the time being, I'm going to just simply make all of them to apply to all subbasins, all months, and say save changes. So now the changes are saved. So again, you can keep track of all the changes that you're making. If you want to delete that, you can simply click right here and delete it and go back and make additional changes or different changes and things like that. You could be changing rainfall in one subbasin, upper part of the watershed, and could be reducing rainfall in the lower part of the watershed. So you can distribute the spatial variability of your rainfall and temperature across your landscape. So once I've done that, okay, so now I want to run the model and I want to see some results. So you can write the output, run the model, and you can, like as I mentioned, you can always click on this time estimate. That will tell you based on this, it's going to take under 2 minutes to run the model, based on the current load and the number of HRUs and number of subbasins and stuff like that. And process the output. So I click simply select. So now the model is running on the server. So like as I said, it could be easily accessed through any smartphones or iPad or any kind of tablets or laptop or desktop computers. All you need is a browser with a decent internet connection. Okay, let me take another second here to complete. So it's completed. So now you'll be able to analyze the output just like what I showed you before. Currently, we don't have an easy way to compare the baseline and the scenario. Now you have to map the scenario separately and the baseline separately. Right now we are working on in the next generation where you'll be able to select not only the baseline and multiple scenarios and be able to compare those results actually. So maybe I'll stop right here. Is there more questions and stuff like that? Or
yeah, we'll spend the last 15 minutes or so just going through some questions. Art, you've been fielding a lot from on the computer on the side. Why don't you go ahead and read them off?
So we have a few questions related to reservoirs and dams. Could you explain how HAWQS models that or kind of the functionality?
okay. So we did incorporate all the major reservoirs. We did not incorporate all the minor. When I say minor, anything less than 25,000 acre feet, which is under the control of USDA NRCS, what they call PL 566 structures. Those structures are almost 80,000 of them around the country. Even though we know the locations, they are much, much smaller than an 8 or 10 or a 12-digit watershed, so they were not included analysis. It's only the major reservoirs are included, and as a part of the SWOT design, all the reservoirs are at the outlet of the subbasin. So if you have more than one reservoir within an 8-digit, they get aggregated and one virtual reservoir is implemented at the subbasin outlet. But in the 10 and 12-digit, most of them are independent because they are all separate reservoir that will be at the outlet of the subbasin. So yes, the server has been incorporated with the best data that is available from the National Inventory of Dams database from the U.S. Army Corps of Engineers.
Okay. We have another question related to land use data. Could you explain the data source and what year we included?
Okay. There are two land use sources of data here. One is the NLCD 2011 and also CDL crop data layer, which is from 2010 and 2011. So we took the crop rotations from 2010 and 2011 of CDL data that gives us whether it's a corn soybean rotation or corn rotation or soybean rotation, things of that nature, or winter wheat and alfalfa, things like that. And then for the non-agricultural land, it's coming from the NLCD 2011 data sources actually. So those two got merged into one database as land use database. Then the STATSCO and the slope from the DEM were used to construct the HRUs for the whole U.S.
A follow-up question was, so we use recently available land use data.
That's right.
Would you recommend using that for, say, the 1970s?
No, I would not actually. Then the problem is we don't have a very reliable national data set in 1970s. The first national data layer is available in 1984 from USGS called LUDA, okay, L-U-D-A, and the next one is 1992 because the next NLCD data was published. So the only way I could go can have agricultural census started from 1957. So we could go back to the agricultural census and find out how much of this county is plowed or what kind of agricultural land was there. Then we can use the land use update menu here to update that land use going backward actually. Rather than going forward, it will be going backward. So we have most updated land use today, but if you want to go back to 1970s or 1980s, we can go and analyze the ag census data set by county, then look at how much of agricultural land that was there then and how much we're now, then we can go back and make the land use change that way actually.
Okay, we have a question related to your current live demo. Person asked, can you increase precipitation by 10% for a specific month, say spring months, and then at the same time increase temperature for a set of other months?
Yes,
in the same
absolutely.
Scenario?
Absolutely. I can show you very quickly how would you do that. So you can come back and say, let's say you want to increase, I'm just picking a number here, and I did not change my temperature, and I can just select only, let's say you want to do this for all subbasins, but for a specific month, let's say month of February only. So I can do only for that, the temperature, precipitation changes, and now I can go back and reset my precipitation and change only temperature this time. Let's say temperature by 1 degree or 1.5 degree or whatever. And now I can select for a different month, for example, April. I don't want to do February, but April. So you can change each variable separately and you keep track of all the changes that you made here, right here. And that's what will be incorporated in the model while you're running the scenarios.
Okay. We have a question related to uncertainty. Can you explain what kind of certainty there is with HAWQS and it's properly calibrated for any given watershed? Are there any built-in features within HAWQS that can compare model results to local flow gauges and my water quality data?
Like I said, we have done the calibration for about 100 locations around the watershed, and we have that table available along with the methodology of how we did, what we did, and what not actually. And we also make the actual water quality data, measured water quality data, that's using the FlexMaster that was used from the USGS to populate, which also has got its own uncertainty numbers in terms of the observation uncertainty. So one could easily compare those results. If you want any other locations other than those 100 locations, obviously we need to go through that calibration process with the local data where the data is available.
Another question was, can you input withdrawals from the model, i.e. irrigation withdrawals or return flows?
Yes, you can input irrigation. Right now, the irrigation is done only as selected sources. For example, if you are in an Ogallala aquifer, the assumption is most of the water is coming from the groundwater. If you are in a western part of the U.S., where there's a major dam, water supply dams, or dams that are used for irrigation from the dams, then it is drawn from the dams actually. But we don't have site-specific sources and site-specific locations where the water is coming for irrigation and things like that. So if the user has that knowledge, they're always welcome to develop the model, download that, and then they can customize to the nth degree with their own local knowledge actually on any model that we can develop in HAWQS.
I think there are just so many questions.
Thanks for all the interest.
Okay. 2 more minutes and then we'll wind it
Okay.
down.
Can you explain the downloading of HAWQS for further customization if we can't provide it in
Okay.
HAWQS?
So when you develop the model here actually under in the main project website, you can go down here, you can say create and zip your project files actually. So when you click on that, it may take a few minutes actually. When I click on that, it's right now zipping the entire folder, both my baseline model and the scenario model, and all the inputs and everything that's required to run the model actually. Then that zip file could be downloaded and can be used with the SWOT editor. If you go to the SWOT website, we have a program called SWOT editor. If you're not familiar with that actually, which is a companion tool. So in the SWOT website, you can download that, or we can make this link available directly in the HAWQS. And the SWOT editor program can be used, which is a non-GIS version. Then whatever the data that you download from the HAWQS would be able to read by this program, and then you can start customizing. You can run any scenarios, or you want to run any calibration routines and things like that. You can do it from right here actually. So right now it's already, so now you can download the entire project file here actually. When you click on this, it will download your local hard drive with all the information that you need, both all the inputs, all the outputs, all the scenarios, and the executable files that's used in the HAWQS system.
All right, thank you. So again, we really appreciate you attending this webcast. We had about 550 people actually register. We see several hundred, so again, a whole bunch of folks maybe on in a conference room dialing in. So we really appreciate that and your engagement and questions. And this webcast itself is a great milestone for us because it sets the stage now to work on the next version. There's, as we pointed out in next steps, there's a bunch of work to be done. And we're going to be in frequent communication. So please check our website. We also have emails of the registrants, so we can reach out and notify you of key activities, or for example, when the webinar slides and audio is posted, as well as we will work through some additional questions that, there's a whole lot of great questions that we're going to work on and post answers to those. So, and then again, we're going to be holding user design sessions. That checkbox that some folks checked to be a beta tester. I just want to let you know what that means when you do check it. And it means that you'll help us identify new features by participating in user design sessions, planning meetings, and providing testing support. So if you're interested in that, to be engaged as part of the project team and help us, even if it's for a brief period, we'd really appreciate that. So that's it. Again, thank you, Dr. Srinivasan, Arndt, and Laura. It's back to you.
All right. Well, That concludes today's webinar. We really appreciate you attending. It has been recorded and it'll be on the EPA website soon. So have a wonderful rest of your afternoon.